Okay, so the other example that we did on the last page of your notes that's on that red sheet is just combining all the different methods that we've learned for solving polynomials. Okay, so in this example here, there's no greatest common factor to factor out. There's not a sum or difference of cubes because those only have two terms, and this one clearly has four. It's not a quartic, it's not a 4 right here. So we're going to have to use the rational root theorem. So the rational root theorem tells us that the numerator is factors of 8, and then the denominator would be factors of 1. So ultimately, whatever we write in the numerator are going to be our possibilities, okay? So different factors of 8. We can do 1 times 8, negative 1 times negative 8, 2 times 4, and negative 2 times negative 4. And those are all our possibilities because the denominator is going to be 1 and negative 1, so that really doesn't really change anything. So these are our possibilities. So you have to get out your calculator and check each one. So I'll just go ahead and tell you that the one that actually comes out to a 0 for the remainder is 2. So we know that one solution is x equals 2. And now I'm going to use synthetic division to find the rest. So remember, if there's nothing in front of the variable, then it's a 1. So my numbers are 1, negative 2, 4, and negative 8. So bring down the 1, multiply up. 2 times 1 is 2. Add that up, that gives you 0. Multiply up, 2 times 0 is 0. That gives me 4. Multiply up, 2 times 4 is 8. I get a remainder of 0. Now remember, I got to fill this back in, and I have to begin with 1 less than the degree that's in the problem. So this is going to be x squared plus 0x plus 4. And you obviously don't need this when you're getting ready to solve it. So I have x squared plus 4, and so now I just need to solve that. So I subtract 4 from both sides. I get x squared equals negative 4, and of course when you take the square root of a negative, that gives me an I. So this is going to be positive or negative 2I. So there's 2 roots, and then here's the other one. So now you have 3, which is what I had in the original problem. So the zeros of the function, or the roots, or the solutions, however you want to call it, would be 2, and positive 2I, and negative 2I.